All right, so these are the notes for the rational transformations. So with the rational transformations, we already know it's going to deal with A, H, and K. So if you remember A, right here, if A is negative, it flips a function over the x-axis, so it reflects across the x-axis. H makes your graph move left and right. The K value makes your graph go up and down, right? So you'll have one where there's not squared and then one where there's squared. So we have the rational function right here. We can see it. So we have two branches, one in quadrant 1 and one in quadrant 3. If you forgot about the quadrants, it's 1, 2, 3, and 4. So if you have y equals a over x minus h plus k, it's going to look like this, quadrants 1 and 3. So again, your a, if it's negative, it reflects it across the x-axis. So what would happen is your branches would go from 1, 3. This one moved to quadrant 4, and this one would move to quadrant 2. And then left and right, actually there's two asymptotes here, and that's actually what's moving with your left, right, up, and down. So we have this vertical asymptote right here, and that's going to be at x is equal to 0. So this right here moves that vertical asymptote left or right. And remember, it's always the opposite of what we see. The k value takes this horizontal asymptote at y equals 0, and it moves the horizontal asymptote up and down. And as it moves left, right, up, and down, the branches do move with the asymptotes. This right here, you'll notice there's a square there. So 1 over x squared is the parent function. The previous one was 1 over x. So when it's squared, the branches, they both go up, right? Again, you still have those vertical and horizontal asymptotes. So the first one is at right here, x equals 0, and then we have one at y equals 0. Again, a reflects it across the x-axis, so both these branches will be facing down. This h moves your vertical asymptote left and right, and this k value moves your horizontal asymptote up and down, and again, the branches do move with it. Okay, and so this is what summarizes it. A reflects it across the x-axis, h left, right, k up, down. Just remember, h is the opposite of what you see. And here we have the basic transformation equation again. So let's go ahead and take a look at some examples here. So it says some rational functions can be graphed using transformations, horizontal shifting, stretching or shrinking, reflecting, vertical shifting of these two common graphs. So determine the parent function, plot the new asymptotes with the transformations, then plot the new graphs. Okay. So again, we'll write this equation here, a divided by x minus h, close parentheses squared, plus k, and I made it squared because that's squared. All right, so right here we can see we have an h value and we have a k value. So this is the opposite of what you see, so this goes left to right. So in this case, this is the opposite, it's going to go right 2 units. And k, it is what it is, so plus 1 means to go up 1. So here's my parent function. Now my transformed graph is the vertical asymptote will move right 2 units, and my k value moves it up 1 unit. And now we just take these branches and we're going to graph them in the same manner. So both of them are going up, so we're going to draw these close to the asymptotes, not crossing or touching, and they're both going up. So we see you have that there, and we have that there. So right 2, up 1. Let's go ahead and take a look at the next example. So this one right here says use this graph. Again, we have 1 over x, so the parent function would be a over x minus h plus k. And you do want to be careful if there's a negative sign, just in case, but in this case there is none. So again, we have an h value and we have a k value. So this is the opposite of what you see, so it doesn't go right, it actually goes left 2 units. And this k value goes down 1. So asymptotes are originally here, just kind of refresh your mind where they're at, the x and y axis. So left 2 moves it left 2. And then down 1 moves the horizontal 1 down 1 unit. And then, like I said, my branches do follow. So they're going to be close to those asymptotes, not crossing or touching, but they should be very close to touching them. All right, and that's going to conclude the notes for transformations of rational functions.